Happy day, students. So today we have a class on 6th day, and today we are going to see interference, reflection in waves in string, not interference. Okay. So reflection, refraction. We know that both happens when a wave moves from one medium to the other medium. As we have studied in light, reflection and refraction. Whenever light moves from denser to rarer medium or rarer to denser medium, reflection and refraction both happens. In fact, not only reflection and refraction, absorption also happens. So we can say that energy is incident of the incident wave, that is distributed in reflection, in refraction and absorption. Okay, who is going to absorb it? The medium. If suppose that in the case of light we have seen that if suppose this is a glass slab. Okay, from here incident rays coming, there is a normal, there is a reflection, there is a refraction. Okay, so this is reflected energy. This is refracted energy, which we will call here as transmitted energy. Reflected or transmitted. And you must have noted that this glass slab also become hotter. It gets hotter. That means definitely some energy has been absorbed also. Okay, so incident energy is utilized in three ways. One is reflected, refracted and absorption. So here in this waves also, the waves that we are talking right now also get reflected and refracted. Absorption here we are not talking right now. So for us, energy absorbed is zero for the moment. Okay, we are going to talk about reflection and refraction alone. But now let's see how we are going to utilize to understand the phenomena for waves in string. Okay, so I am writing just for the reflection first. Reflection in wave produced in string. Produced in string. Okay. Now in this also there are two ways. One, when string is fixed at one end. When string is fixed at one end. Okay. Something like this. We have fixed it. This end is fixed. What is the meaning of fixed? That means it cannot move. It is at rest. It is stationary. So what we are doing, this end is free and at this end we are going to produce a pulse. Let's say we produce this pulse and it's going. Okay. At some point this pulse will reach here and then after this it will become like this. Now this end is fixed, we all know. Now what is going to happen? Now here we will say that this is a medium. Okay. In this medium, this is, you can consider it is similar to denser medium. Okay. This end is fixed. Now what will happen? As we studied in the previous topic, in this part here, tension tries to pull the string in this way. It's pulling it. Okay. Because here change in length used to be maximum as we studied in the previous topic. Okay. So tension is trying to pull it over here, but since this end is fixed, according to Newton's third law, reaction force is going to pull this string in this way. That's a reaction force. Okay. Now we have to understand, can this T pull this point over here? Answer is no. But can this reaction pull this string this side? Answer is yes. Because string is free, it can move downwards. But tension cannot move this point because it is fixed. Okay. So reaction force will pull this string downwards. Second point that we have to remember is, because we are talking about reflection and we know that in reflection angle of incidence of the wave with the normal will be equal to angle of the reflected wave with the normal. So what pulse is this? This is incident pulse. What is normal here? This is normal. Normal to the surface. This is the surface. Okay. This is normal. So this is angle of incidence. Okay. So how will be the reflected wave? Reflected reflected wave will be like this, and this angle will be same as that of angle of incidence. You can call this as angle of reflection. So now how will be the reflected wave, we will see. First I explained you the concept. Okay, what are the two major points we have to remember? One, reaction force. This reaction force is able to pull the string downwards, and second concept is law of reflection, which says angle of reflection will be equal to angle of incidence. Now see, same diagram I am making again, and I will make you understand that how reflected wave is coming up. Okay, so see, first this is our pulse which is going towards fixed end. It's like this. Next, this pulse reached here. Okay, like this. Then what will happen? This reaction force, angle of incidence, angle of reflection, next incident it will be like this. It will become straight. Why it will become straight, that also I will explain you. Give me a little time. Then the reflected one. It's going like this. Okay. Now since in this one and this one, incident one and reflected one is on the same string. Okay. So wavelength will remain same. That means what I am trying to say is propagation constant is same. Okay. What is the property of the wave which do not change with change in medium? That property is frequency. If that is frequency, that means omega also will remain same. Okay, if omega is same, k is same, that means wavelength also is same. Okay, and one more thing, in this one we are assuming that entire energy is getting reflected. There is nothing to be transmitted on that side. So if entire energy is getting reflected, then remember, whatever is the amplitude of incident wave, same is the amplitude of reflected wave also. Okay, incident wave and reflected wave in this case have same amplitude. That means we are saying that it is a complete reflection. Okay, nothing other than that reflection is taking place over here. Are you getting? So did you understand the formation of the wave? Further I will explain you after a little time that how it is happening, how can we find the shape, and all that I explain you. But this is how the things are taking place when the one end is fixed. If the pulse is going from the top, the reflected waves coming from the bottom. Here the phase is changed by pi radians. Okay, it was going from the top here, reflected waves coming from the bottom. So here phase has changed by pi. Phase changed by pi radian. Okay, reflected waves phase and incident wave phase difference is pi. Okay, so if suppose the equation we have to write, if incident wave equation I write is moving towards positive x-axis, something like this I am writing. Y incident is a sine of kx minus omega t. Then y reflected definitely is a sine kx minus omega t plus pi. Pi is the phase difference. Okay. Further you can write it in other way also. A sine, this is pi, so I will write this pi plus kx minus omega. Okay, sine pi, pi plus means it's in third quadrant. Okay, if it's in third quadrant, what will happen? This will become minus a sine kx minus omega t, or you can write this as a sine omega t minus kx. Okay, so a sine omega t minus kx means what? The phase has changed. Are you able to understand? Here is kx minus omega t plus pi, because we have changed the phase by pi. If we solve it in this way, what are we going to get? We are getting sine of kx minus omega t minus omega. So this became omega t minus kx. So this way we can find the equation of reflected wave if the incident wave reflection is given to us. Okay, now one more thing we will see. Reflection of the wave in string from free end. Right now what we saw? Reflection of wave through fixed end. Now we are going to see through free end. That also you see. Okay, how it's free end? Something like this. That means this end of the string is attached with the ring. Okay, now what will happen if I am going to produce one pulse here and say that it's moving in this way. The next instant, let's say it reached here somewhere like this. Then what will happen? It will go like this. Okay, after that what will happen? Like this. After that, now this is reached the top here. Now what will happen? Now entire energy of this pulse has gone into this ring and it has gone into the topmost point. Now what will happen? That ring will come down. At the next instant, to make it like this, the next instant, see, right now it's like this. Next instant it will come down. Okay, then it will come further down. And this will start moving in this direction. Are you able to understand? This pulse, when this came down, this pulse generated here. When this comes further down, it becomes like this. Now this pulse is going back. So this is reflected pulse, a reflected wave. Okay.